Alright, so the first thing that we need to talk about here is no, these students are not idiots. No, they're simply misguided. Students are not idiots. So, let's see what's going on here. Andy says the magnitude of C is 5. So if we have vector A, which is, let's say each of these squares is 5 units, whatever the units are. So that's vector A, and then we're adding vector C. And we don't know the direction of vector C specifically. So maybe it's like this. It's 5, 10, 15. Or maybe vector C goes like this. We just don't know the direction. But we do know what some possible directions would be. And that's what we're going to be looking at here. So let's dissect each one of these students' claims and determine which students are the most misguided. So we have Andy who says the magnitude of C is 5. If A is 5, B is 15, the resultant C will equal of A plus B. How do we add 5 and 15 to get 5? That's a little suspicious, Andy. I don't know. I'm going to mark you down for maybe. Bernard, magnitude of C is 10. How do we get 5 plus 15 to equal 10? Well, if vector A goes in this direction, 5, a length of 5, and vector B, tip to tail, goes 5, 10 in this direction, vector B is 15 in this direction. So that would leave the remaining length, this extra piece right here, the resultant, to be 10. So Bernard, that's reasonable. If you know the direction, if you know the direction is exactly opposite, that seems reasonable. Cliff, the magnitude is 15. How could we get something close to 15? Because I don't think we can get 15. But if we have this is 5, and we say this is 15, this right here could be something similar to 5. Using Pythagorean theorem, you would do 5 squared plus 15 squared, and that would give you whatever, 250. And then take the square root of that, and that's going to be something like 15.8, 15.9. That's close. Cliff, it seems like you're probably a little bit wrong there. I don't think we can add 5 and 15 to get 15. We can add something a little bit to get a little bit close to 15, but not quite 15. Daniel, the magnitude is 20. Okay, that's easy. If vector A is 5 this way and vector B is in the same direction and it goes 15, then we know this total length here is going to equal to 20. Okay, Daniel, you know what you're doing. Edward, the magnitude is 25. I don't know how you get 5 and 15 to be 25. So it looks like our winners for most misguided are Andy and Edward. Would be the two students, and Cliff, you're a little bit off there. All right, next up. Vectors A and B are shown below. Show the resultant of each of the operations indicated. So if we have vector A and vector B, those are the two vectors. So for this first box, we want to see what is A minus B. So to do A minus B, remember, we add the anti-parallel B. So A goes up 1 and to the right 3. Puts us right there. And then B goes down 1, 2, and to the right, left 1, 2. So anti-parallel, B is going to be go up 2 and to the right 2. So up 2 and to the right Man, I can't see. 2. Okay, so our resultant vector in that instance will be from the start to the end. There's our resultant in this direction, a minus b. On to the next one, now that it's a little bit more readable. Anyway, now b minus a. So let's go ahead and start with b. So it's 1, 2, and 2, right? So that's vector b. Vector a, anti-parallel. So this goes up 1 and to the right 3. So we're going to go down 1 and to the left 1, 2, 3 for the resultant vector to be in this direction. There's our resultant. 2b. 2b goes, well, b went down 2 and to the left 2. So twice b would be down 4 and to the right 1, 2, 3, 4. There's 2b, twice the magnitude of b. Half of b, that would be down 1 and left 1. And then negative 1/2 b, that would be up 1 and to the right 1. All right, next problem. The vector v shown starts with components 40 and 30 at t equals 0. Each second, the vertical component decreases by 10. So that means answer the following. When is v the shortest? Let's see. So if we're decreasing by 10, after 1 second, we're right here. After 2 seconds, we're right here. After 3 seconds, our vertical component is 0. And then after 4 seconds, it would be negative 10, 1, 2, 3, 4, 5 seconds. 6 seconds, it would be all the way down there. So when is the vector v the shortest? All right, so maybe it'll help if we draw out each of the vectors. So if our vertical component is decreasing by 10 each second, then after the first second, that would be v. After the second, that would be v. After the third second, that would be v. After the fourth second, that would be v. Fifth, and then finally the sixth. All right, so where is it the shortest? We can see that at 3 seconds, vector v is the shortest. What is v's shortest length? 40, right? When is v, again, the same length it was at t equals 0? That was all the way at t equals 6 seconds.